digitalization of the construction sector, or if I click now. Very briefly about me. Let's see if I can. I work in the Department of Construction Engineering and Lighting Science at the School of Engineering, Linköpings University. I started working there in 2015, and January last year I started working also at Linköpings University, the Division of Construction Logistics at the Department of Science and Technology. I have a background as an architect, and I do teaching and research. When I click, it's not moving. So let's see. As I said, the topic of this presentation is the digitalization and how digitalization can enable sustainability for our sector, the construction sector, or the built environment more in general. And I believe that digitalization can enable sustainability by enhancing efficiency, reducing waste, improving monitoring, or helping us with reducing waste, improving monitoring, contributing to better decision making, cutting time and costs during the construction process, allowing the creation of digital models to predict and control buildings' performances, and many other possibilities we have with digitalization. I will mention others during the presentation, and then maybe we can discuss also at the end. I also believe that some digital technologies that some already exist and we have been using for many years, others are emerging, but the technologies I'm familiar with are building information management or modeling, BIM, geographic information systems or GIS. Digital product passports is a new topic we are discussing more and more now, and I'm doing research around that recently. Artificial intelligence is another topic that we cannot, another technology we cannot ignore anymore. So those are some of the technologies together with the infrastructure we need and the competences and everything around those technologies. But those can help us during the journey toward digitalization, I believe. So in this lecture, I will tell you a little bit about the digitalization in the construction sector, a very brief historical introduction, if you want, and then telling you what I mean with sustainability in our sector, and a little bit more about the technologies I mentioned and how they can help us and where are we now. And then some warnings, because digitalization doesn't come for free. There are some things we have to consider, and then again, maybe we can discuss and see if you agree with me or not. So the historical introduction. We used to work with on paper with some different tools. Before starting architecture, before starting university, I was working in an architecture office, and the first assignment I got was to translate the paper drawings in CAD, in AutoCAD. We started this. That was, I think, one of the first stages of the digitalization or digitization, because that was really from analog to digital. So that was more digitization than digitalization. And one of the reasons why I believe some companies started doing that was, maybe they could save some space. They started seeing the value in storing data in another way. But also we moved from this kind of tools to draw to this kind of tools, like the digital tools that made the drawings and the editing mainly of the drawings much faster. So that was the first sign that when I believe companies started seeing the first values in digitalization. So we could save space, we could save time, therefore we could save money, And that was, I think, a good driver to continue towards the digitalization process. Then towards the end of the 90s, some software started entering the market, and they were the modeling software, what we could call now BIM software. But in many cases, and I believe it still happens now, those software were used or are used mainly to create 3D models, to facilitate maybe the 3D visualization, which is important. It's definitely an important aspect. Maybe to get quickly some drawings, plans, sections, elevations, which we before we were drawing from maybe from in CAD. So it was another way to draw as we were doing manually, but in CAD. And this software made this process faster. Then at the beginning of the 2000s, more and more software for analysis and simulation started being used more and more. Here I have just some examples. As an information, I'm using pictures. Some pictures are mine, some I found online. At the end of the presentation, there is the reference. There are references to all the pictures I took. So this is an example of a lighting simulation, cost analysis, clash collision, energy analysis, and you name it. We can run very many analyses that can allow us to understand, as I said, the cost, to predict the performance of a building, to control the quality of our 3D models, to run the whole life cycle analysis. We have software for life cycle analysis. So those software add a value to the 3D models. So we could use the 3D model to take better decisions, to optimize the final results. And that was able, and something that enabled that was the possibility to add information, specific information to the different elements of the model. So the information as a value for designers or for whoever is in the process to be able to then simulate, analyze, and then take decisions. Then when I speak about information, something that in software, like the one I'm showing you is Autodesk Revit, it is called parameters, or if we speak about elements, they might be called product information by the manufacturers. But what we are talking about are technical details that we can implement in the elements, in the 3D elements, so that we can use them in another way. Then you are all you all know that in the last decades, other technologies started being used more and more, like Internet of Things, which is a technology we need for digital twins, smart cities, augmented reality, which started being used in construction sites, for example, virtual reality, I know is used by some companies to train workers, for example. And then we have, as I mentioned before, artificial intelligence and machine learning, which is one branch of artificial intelligence that show other possibilities, and that allowed us or companies to think about how to use all the information they've been gathering during the years, for example, or another way to gather information. Or we have natural language processing that started that gave ideas about other kind of tools. Now, this is something I didn't test myself. I found this video, but this is, for example, a possibility to go from text to BIM, which I don't know how it works really. I didn't test, but yeah, anyway, those technologies open up for a lot of possibilities we can have in the future. Now from the video, let me, yeah. So that was a brief historical introduction, I would say. What do I mean with sustainability? We know that the definition of sustainability includes environmental sustainability, social sustainability, and economic sustainability. So we say that when we actually reach the all three aspects, then we have sustainability. If we take the whole three aspects into consideration, we have really sustainability. And we also know that the construction sector has a very high impact can have a high impact on the environment. Where we build, the decisions we take, the regulation we follow, we have to follow, the kind of material we choose, where the materials are produced. So those are all decisions that we take and that have an impact on the environment. The same is for social, where we live matters, and the way we live, the infrastructures that we have or we don't play a big role in the kind of life that we or our children can have. And economic, it's all those topics are huge topics. Now I just take an example, but often when I think about economic growth, I also think about the energy consumption, that the energy that we need for to grow or to run our industries. And when I think about energy, I think about how we produce energy. And of course, we would like to use renewable energy rather than fossil fuel, but then we have also to take into consideration how we produce. And then we go back to the social and the environment, of course, because not only by definition, but they are definitely connected. So then how can those digital technology help us in this journey, and what technologies, and where are we now? So I said I've been working most of my career in both teaching and research, mainly with geographic information systems and with building information management. And something that they have in common is information. Information as a value, information as something that can actually allow us to use these tools at the best. So what is information then? I usually show to my students this pyramid. Like we start from data. What is data? So data is a basic fact. It's a red dot. If I put the data in a context, I give an information. So a red dot in such a shape tells us that that's a light. It tells us something. It's an information. If I give a meaning, so I give a function, I give a meaning to the red light. I put the red light on a crossing. From that I get knowledge. So I know that that actually means something. If I have a red light on the crossing, I have to stop, because if I apply my insight or my wisdom, I know what can be the consequences if I do not stop instead. So, but this is the long story. But so going back to information, then we say that information is data in a context. And working with BIM and GIS, I've been working with two different contexts. So a building context, or a geographic, or an urban context. And so the different contexts require a different information structure. So we have still information as a core of the tools, but the structures are different. And also the results, of course, because we work at different scales. So the information structure of GIS is an information structure. It's a structure where the information are shared in vector data or raster data. When we speak about vector data, we have points, lines, or polygons that represent something from the reality. We have a generalization of the reality because of the scale we are working. We usually store this data in databases or geodatabases. And something that it's very useful in GIS are called attributes, so are the non-geometrical data that we can add to the geometrical data. And the analysis of the tools that the software provide us with help us analyzing the geodata from a geometrical point of view, but also in more complex ways, where we can also take the attributes into consideration, and we can visualize a big amount of data, and usually on a map, because the geographic context is the one we are looking at when we work with GIS. Sorry. And of course, AI is also something, or machine learning or advanced tools entered also the GIS market. And so this is a screenshot taken from Esri website, where they started developing AI tools for faster analysis, more accurate analysis, prediction, and so on. The information structure in BIM is what I was telling you before. The information are added to the different objects usually in a building, and they are often technical data. But what we want in BIM is to have information. We want to start collecting the information we need during the whole chain from the very beginning, ideally from the planning, and then the level of information augments as we proceed. On the circle you can see on the left of the screen. So we add information as we move along the circle, but we want this information to be saved. We want to be able to retrieve those information. We want to be able to go back also. So and we want the information to be available during the whole life cycle of the building. And when it comes to the information we can add in a BIM model, or how we use those information, or how we integrate this information, we often speak about the BIM maturity level, where at level 0 we have no BIM. It's we are still working with CAD. The level 1 is what I showed you in the previous slide, when we start working with 3D, but mainly for visualization. Probably we do not use the full capacity of a BIM model. Level 2 is what I believe we started recently working more, and it's where we work with the BIM models, where we add information, where we use this information for analysis and simulation, where we use also other software. And then what we aim to is to work on a level 3 and beyond, where we work with standards, IFCs, a common standard for BIM, where we work in an integrated way when we consider the life cycle of the building, the life cycle management. Something I mentioned at the very beginning is also digital product passport, because when we speak about the information, we have to consider also from where do we get the information. And if we are in a building context, we want to get this information from the different objects or products that we have in the building. And those information usually come from the manufacturers, but there are also information that we should start gathering before. And then digital product passports, I don't know how much you're familiar, or who among you is familiar with them, but it's something that many manufacturing companies start being aware of, and maybe even a little bit scared, because there is a EU regulation that says that by 2030, I'm not 100% sure about the date, so sorry if I'm wrong, but quite soon, all products in circulation within the European Union need to have a digital product passport. And digital product passports are technology that are supposed to gather information about the product during the whole product life cycle. So from the material extraction to the elaboration to the production and the use and then the end of life of the product. So the disposal or the reactions like reuse, recycle, refurbish, whatever. The many are actions that are possible. So I started, so that's what, yeah, sorry, I started speaking about the other slide. So here you see the circle that it's very similar to the one we have for BIM. So it's a circle that includes the whole life cycle. And digital product passport should be for all kinds of products. So the first products that will be requested to have digital product passports are batteries and electronics, and then I think it's textile. Our products, the product we use for buildings come a little bit later, but it's coming anyway. And there will be the hub of information, and also they allow the possibility to gather information. I started working on digital product passports quite recently in a research project I'm managing. It's called ProFlow, Prototype for Products Information Flow. When we started working on the digital information to achieve circular economy, and then we couldn't skip the digital product passport. We ended up working on digital product passports, and we started working with ontologies some years ago, and there what you see on the right side of the screen is the conceptual graph to then for us to then build an ontology about the digital product passport of a lighting fixture. Our main partner, this project is co-funded by Vinnova, and our main industrial partner is Fagerhult, and we use one of their Fagerhult Belysning, and we use one of their lighting feature as a case study. And this, what you see, it's also only one part of the graph that we built, because then, for example, there is one module here, which is material, from which we developed another graph as complex as the one you see. So to say that digital product passports are going to be a very interesting tool for us to also to gather information and to have in complex and complete information about the product, but they are they're quite complex, and we are also writing right now another research project to focus more on digital product passport. But where are we now? Again, some years ago, I started working on a research project for smart built environment. Smart built environment, for those who are not familiar with it, is probably the biggest governmental program to support research projects for the construction that aim to improve the construction sector. They believe that the integration of geodata, industrial process, and BIM could help the Swedish sector in improving digitalization and industrialization. And when they started, they had 4 long-term goals that they wanted to reach, they aimed to reach by 2030, and they were they regarded the decrease of 40% of the environmental impact in construction, decrease by 33% the time, and by 33% the costs of the construction, and then they aim to create new business models and new actors. And then they had 26 short-term goals. I say had because then those goals were revised, but those were the first, those that they launched the first time. And I will not go through all the 26, but among them there are topics that aim to improve digitalization, other that aim to improve industrialization, and among those for digitalization, there are open data, access to open data, integration of BIM and GIS, and object-based information as a contractual status, and so on. So the project I was involved in was titled MET-metoder, so measurement methods, and the aim of the project was to develop metrics to measure the status of the digitalization and industrialization of the sector. So in order to improve, to say that we are doing better, we have to know what's the starting point, and that's what we try to measure. I was responsible for the part of the project run at Linköpings University, and Susanna Engström, a colleague of mine working at Luleå University of Technology, was responsible for the industrialization. So I do not have time to share all the results, but we interviewed people sitting at the board of Smart Build Environment. We interviewed practitioners. We ran a survey, and we received some interesting results. And one that I share with you now is that, for example, a big issue was in regarding the definition. We saw that the different actors had a different definition of digitalization. So we were not even talking about the same thing. So we had some of the actors involved in the process talking about scanning paper to have PDFs as a digital improvement, while we had others saying that a PDF is not even digital because they couldn't gather automatically the information, the data. So for them, a PDF was just a piece of paper in a computer, something like that. So we didn't agree on a definition. And then we also found other issues like the lack of laws and regulations, the need of working methods and organizational structures. We saw that we have the technologies, we have a lot of different tools and technologies, and what we needed, or what we need, are working methods and also competences. For my PhD thesis, I worked on the integration of BIM and GIS, for example, and from a technical point of view, I developed my own web software where I could work at the same time with the two tools. But then that was a topic some years ago. For example, and I believe that was what we needed. The integration of BIM and GIS was one of the 26 short-term goals for Smart Build Environment. But then, talking with the practitioners, with the different actors running the surveying and the interview, it came out that, well, that we have the technologies. What we don't know is how to use them. So integration doesn't necessarily mean integrate them in one software that can do everything. It's actually maybe having people who can work with both technologies, and this is just an example about one of the methods, organizational structures we discussed during the project. The mindset, we often talk about the mindset, and it's a little bit true. I don't think that the construction sector is this static sector that doesn't want to change, but sometimes we do not have the time to consider changes, and if what we do works, we tend to keep doing the things in the same way. But yeah, that was one of the other things that emerged, and the need of seeing information as a value and an asset. And this is something that I believe now artificial intelligence, machine learning is changing this. Before, we saw information as something we could save storage for some years because we might go back and need. Now we have those tools that show that if you have good information, good data structured in a proper way, you can actually get some very advanced analysis. Maybe you can you can use them in a very different way. That was between 2016 and 2018 that the project was talking about. Currently, I'm working together with, I'm co-supervising Kefa Kafolo, my PhD student at Linköpings University, together with Martin Rudberg, who is his main supervisor. And we also, mainly Kefa, but we have been running interviews with, again, different practitioners, experts in the digital transformation. And we are writing now a conference paper titled Digital Transformation in the Construction Industry, Overview, Challenges and Drivers. And again, I cannot share, unfortunately, all the results because of the time, but we saw again that there are some challenges if we talk about this digital transformation. And there's some challenges are very similar to those I mentioned before. Like we have some internal challenges, so within the companies, mainly meaning the organization, the structure, the way we work. External, we have the market, of course, who is that we have to take into consideration. Laws, regulations, standards. We have a lot of standards in our sector, and sometimes they're followed, sometimes they're not. There are not so many standards about how to work within an organization, maybe. Regulation, I mentioned. And then, yeah, the fact that our sector is very fragmented, or that there are really many actors and different stages. So that makes things a little bit more complex than maybe other sectors. But we also saw that there are drivers for digital transformation. Safety emerged as one of the drivers. Clients, more and more clients demand companies to work in a more sustainable way, meaning that they need to start working with some technology that enable this sustainability. Yeah, technology, as I said, we have a lot of possibilities when it comes to tools and software and so on. Regulations can be a driver, and sustainability emerges as one of the drivers for the digital transformation. So to approach the end, warning. I'm not the only one, of course, who thinks that digitalization can be a driver or can open up for possibility for sustainability. But here you see, I take a screenshot from the webpage of the UN Environment Program, where they say that the technologies, the use of technologies, can open up for a lot of opportunities, but also risks. And speaking about risks or warnings, I said that digitalization can allow sustainability, but also the other way around is possible if we do not consider, if we do not look for alternatives or other possibilities. Energy consumption, for example, we need a lot of energy to run data centers and centers for networks. I mentioned digital product passports, and we are speaking about saving data about products for the whole life cycle, and many products have very different life cycles and different lifespan. And I had a meeting yesterday with Trecentrum and TMF, who are partners in our will be partners of the research project I'm writing about, and the representative from the Tre Mobler for TMF said that they are actually discussing about having a copy of all the passports. So maybe for each product we have two copies of the passport. It's a huge amount of data we're talking about, and those data must be saved somewhere. E-waste, yearly, I do not have the numbers here, so I will not attempt any number, but you know that so every year we dispose a lot of technical e-devices, and that creates a big amount of waste. Carbon footprint associated with streaming and cloud services, and resource extraction. We need natural resources, and that alone goes back to the whole circle of sustainability, because it has an impact on the habitat, on the energy, on the pollution, also on the environment, and on social, on with a number of social issues involved on that around that topic. So to conclude, I still believe that digitalization can enable sustainability. I believe that we have a lot of things to think about, and I close this presentation with a picture I got from the ChatGPT image creators. Like, I asked to create sustainable digitalization grow, and what you see, it's quite messy. And then I thought that technology alone cannot really help. We cannot rely only on the technology. We need to put more on that, but we can get quite some help from it. So that was all from me, from the presentation. I hope you have some questions. Thank you for listening.